Welcome to Exam Room Series. This series is dedicated to helping you ace the air traffic controller exams. We'll break down everything you need to know, from regulations to procedures, to help you achieve your dream of becoming an air traffic controller. In this session, we're diving deep into a crucial safety system, the Airborne Collision Avoidance System. It's designed to prevent mid-air collisions, and a solid understanding of its principles and procedures is vital for both the exam and your future career. Let's start with the basics. What is transponder?
A transponder in an aircraft is an electronic transmitter and receiver device that transmits a unique 4-digit octal code called identification code, or a squawk code. When interrogated by a ground radar system, allowing air traffic control to identify and track the aircraft's position on their radar screen. Now we will understand the transponder operating procedures.
There are 3 transponder modes of operations: standby, auto, and TARA mode. When an aircraft parked at gate or standby mode shall be selected. Transponder will not send interrogation pulses, thus, there will be no TCAS warnings during standby mode. Auto mode will be selected when aircraft pushbacks or taxi. This will not generate RA warnings, but aircraft ID will be displayed to ATC radar system. When aircraft is on runway or in air, transponder is set in TARA mode. This will generate traffic advisory and resolution alerts to the pilot.
As per DGCA, what are the pressure altitude reporting transponders requirements in Indian airspace? Aircraft with a maximum certified takeoff mass of 5,700 kilograms and above, a passenger seating configuration of more than 30 seats, or a payload capacity exceeding 3 tons must be equipped with a Mode S transponder to operate in Indian airspace.
What exactly is TCAS? TCAS stands for Traffic Collision Avoidance System that helps pilots identify and avoid other traffic without the need for air traffic control. What are the types of TCAS alerts? TCAS can generate 2 types of alerts to pilots: traffic advisories TA and resolution advisories RA. The traffic is displayed on the navigation display along with an indication of its relative altitude. Traffic advisory TA alerts the flight crew to potential threats, enabling them to visually acquire the traffic for. With 45 seconds to go until the closest point of approach, the system issues a traffic advisory, such as traffic. Resolution advisory RA provides an indication to the flight crew, recommending a maneuver to establish separation, or a maneuver restriction to maintain existing separation. With 25 seconds to go until the closest point of approach, the TCAS warning changes to a resolution advisory. The TCAS computer on the other aircraft coordinates to give an opposite direction command: descend, or climb.
Indian regulations on TCAS. The Directorate General of Civil Aviation mandates the TCAS 2 version 7.1 for all aircraft operating in Indian airspace. TCAS equipment must meet the specifications contained in Annex 10, Volume 4, to the Convention on International Civil Aviation. Every flight plan for a flight in the Indian airspace shall indicate that the aeroplane is equipped with a serviceable ACAS equipment required as per CAR Section 2 Series I, Part 8.
Which are surveillance sensors used by TCAS? TCAS relies on a combination of surveillance sensors to collect data on the state of intruder aircraft, and a set of algorithms that determine the best maneuver to avoid mid-air collisions. These sensors are transponder mode S, onboard computer, flight deck audio and display system, altimeter, and 2 set of directional antennas.
How TCAS works to prevent mid-air collisions. The TCAS system has an onboard computer in the aircraft avionics compartment and 2 antennas. The top antenna scans the area above the aircraft, and the bottom antenna scans the area below. The TCAS computer collects data from the aircraft systems and creates a 3-dimensional area of protected airspace around the aircraft. The onboard TCAS computer sends interrogation signals to other aircraft, which respond with their identification code and altitude. By tracking the direction and measuring the time taken for the response signal, the TCAS computer locates the position of the other aircraft. It then calculates the airspeed, vertical speed, and heading of the other aircraft using changes in altitude and position over time. Finally, the TCAS computer determines the closest point of approach, which is also called collision point, whether the other aircraft's path interferes with the protected airspace, and how much time is left until the closest point of approach.
What are the different types of TCAS? There are two main types, TCAS 1 and TCAS 2. TCAS 1 provides traffic advisories only. TCAS 2 provides vertical resolution advisories, RAs, in addition to traffic advisories.
Now we should understand the TCAS RA procedure laid down in DGCA Civil Aviation Requirement. Pilots are required to comply with all resolution advisory, even if the resolution advisory are contrary to ATC clearance. During TCAS RA, the controller is no longer responsible for separation of the aircraft involved in the resolution advisory. The display of a traffic and resolution advisory is accompanied by an audio alert like, traffic, climb, increase descent, or maintain vertical speed, to inform the crew that a resolution advisory has been generated. Once the intruder is no longer a threat, TCAS will announce, clear of conflict. The controller's responsibility resumes when the aircraft reports clear of RA.
What is false RA? A false RA refers to a situation where TCAS issues a resolution advisory warning, instructing the pilot to take evasive action to avoid a potential collision, even though there is no actual imminent threat, often caused by factors like high vertical speeds close to a cleared altitude, leading to a false positive alert. Pilots can minimize the risk of false RAs by reducing their rate of climb or descent to around 1,500 feet per minute or less, when an aircraft is 2,000 feet away from its level-off altitude.
What are the limitations of TCAS? TCAS, like any system, comes with quite a few limitations. TCAS relies on other aircraft should be equipped with a transponder. These transponders should be working and capable of transmitting mode Charlie altitude information. The maximum tracking range of TCAS is 14 nautical miles around the aircraft. Any traffic outside this range will simply not be displayed. TCAS can usually track a maximum of 60 aircraft at any given time, and display up to 30 of them. TCAS will fail if input from the barometric altimeter or main transponder is lost. In some aircraft, a loss of other air data systems or heading reference systems can also result in a loss of TCAS. Stall warnings, ground proximity warnings and wind shear warnings always take priority over TCAS.
That brings us to the end of today's session. We hope you found this overview of the transponder operating procedures and TCAS information helpful. Remember, a solid understanding of these rules is crucial for success on the ATC exam. Join us next time as we delve into specific ATC procedures and best practices. Until then, keep studying and aim high.